Canon Controls is your gateway to mastering LabVIEW. Dive into programming for data acquisition, industrial communications, and manufacturing automation. Explore how to enhance your projects with cybersecurity best practices. Join the journey to elevate your skills and secure your systems with every episode.
Hey everyone, so today just wanted to talk a little bit about how to integrate LabVIEW with different web technologies, web services, tools that are out there. Yeah, let's just dive right in. So first off, just wanted to talk about what is a REST API or a RESTful API. So REST stands for Representational State Transfer. REST is not a communication protocol. So HTTP is the actual protocol, which is built on top of TCP. So REST isn't a communication protocol. It's an architecture that defines the API constraints. So just remember, HTTP is the actual communication protocol. REST just defines how that HTTP data is used. So most REST APIs are going to transfer data in JSON format, and that is pretty much always the case. There are instances that do use HTML or XML, and some could use just like a plain text string or something like that. But most of the time you're going to be working with JSON. And this is a stateless communication. So each request is basically separate from any other request. You don't need to do, a request before making another request, etc. Everything's just totally stateless. That's part of the design of a REST API. One thing isn't dependent on a different one, which is a little different for us LabVIEW developers who are usually used to kind of a, initialize, configure, do, close type, workflow with whether that's working with hardware instruments, whatever. Basically, we're just making a request to an endpoint, and that endpoint serves some function, and it's not dependent on what other requests and whatnot are made. And so what uses REST? So there's a whole bunch of stuff that uses REST. One example is InfluxDB, and there's an example of an InfluxDB, the kind of explaining their API for a certain function. MongoDB, another database, and here's an example of them using REST. LabVIEW web services use REST. So when you're creating a web service in LabVIEW and you define different methods, whether they be get, put, post, delete, whatever, this is all built on REST. And a lot of modern PLCs as well now support REST APIs. So not only can you communicate with your PLCs with like Ethernet IP or Modbus, a lot of them now are supporting REST, which is opening the door to, working with PLCs in a whole different way. So what are the advantages of using REST? So because REST is totally stateless, it's very easy to scale your system when using REST. We can just add new endpoints, new methods, and we don't necessarily have to worry about those breaking other things. When you have like a big monolithic software application, if you're adding new features or changing features or whatever, there's always a risk that you break existing code when you do that. With REST, that's really mitigated because each endpoint is basically its own little module, you could say. And so if you're editing a specific method at a specific endpoint, you're not going to be impacting other things by doing that. So it makes it easy to scale, makes refactoring and maintenance very low risk as well. Thanks to it being stateless, it also makes it really easier for multiple developers to work on the REST API at the same time, just because these different endpoints and their methods aren't necessarily going to interact with each other. So it makes it really easy for people to work on stuff at the same time because you don't have to worry about how everything needs to work together and whatnot, and changes you make affecting changes that other people make. Also, this is a very fast and lightweight way to request and send data. You can send very large payloads and get very quick, responses from different web services. And also the data format is flexible, so you can customize it to meet the needs of your project or customers. So like I said, JSON is the kind of the norm for the way data is transferred, just due to the nature of JSON, with it being just a hierarchy of objects. You can have really complex data structures with massive amounts of data, and they can be kind of customized. They could be as simple as transferring a single value up to, hundreds of values. So, and that can all be ordered, however you want. So it makes it a very flexible way to transfer data. You're not necessarily constrained by only being able to send certain data values or whatnot. It's really up to the API designer on how they want to transfer that data. So as I mentioned before, REST is just an architecture used with the HTTP protocol. Your requests in REST are always going to consist of an HTTP method. So that some examples would be get, put, post, delete. There's also like head options, stuff like that. But this is the meat of it. Get, put, post, delete is going to be the majority of what you're going to be doing with REST. You're also going to need a URL and an endpoint path. Depending on the specific API that you're using, you may or may not also need headers. And we'll talk about kind of what that means. I also just wanted to highlight HTTPS is basically the encrypted version of HTTP, which allows you to securely transfer data. So when you get to go to like a website on the internet and you see that little lock next to the URL, that shows that it's an HTTPS website and not HTTP. So just like that, you can also encrypt your data during transit with REST. And this is not always the rule, but most commonly, those four main methods that I mentioned. Get is going to be used to read data from a server. Post is used to send data to the server. Put replaces the current data at the target resource with the newly sent data. And delete removes data at the target resource. Now that is not always the case. There are instances where like a post, for example, will actually be used to get data. Not always how these are used, and it is up to the API developer on how they actually implement that, but this is commonly how this is kind of done. So now let's kind of dive into it. How can you actually start programming with REST in LabVIEW? So first off, just how to get started. You might want to find some different REST APIs that you can start working with that are just already existing instead of having to create your own. So just Googling like free REST APIs is a good way to find a whole bunch of free REST APIs you can just play with, and you can run queries on, and see data coming back and forth, and just learn how this works. So there's tons of free tools out there, and so you can find APIs that provide all sorts of different information. It could be local weather, it could be random jokes, it could be price of Bitcoin or different stocks. It could return pictures of animals, all sorts of stuff. So there's a million things out there. I included a link to one just massive list, as you can see over here. It's just, these are just endpoints you can use. You don't need to pay any money. You can just play with them and get data back. I have one example here, and this is the most simple example of using REST APIs in LabVIEW. So from that website, we have this free REST API URL, https catfact.ninja/fact. And so what this does is you do an HTTP GET to this URL, and it will just return a random cat fact. And so how we actually implement that in LabVIEW, if you go to the data communication palette, there's a protocols folder. In there, there's an HTTP client folder, and all of your HTTP client methods are in there. The only thing we need for this simple example is the URL we want to do the HTTP GET on, which in this instance is just the catfact.ninja/fact. It's going to return to us headers and a body. So the header is defining the protocol, the version of the protocol, We get a status code. So 200 is a good thing to get. It means it was successful. We get an OK. And then it also includes some other headers that the server responds. And what it actually, the headers you get is going to vary based off of the REST API you're interacting with. But commonly, yeah, you'll get like a date time. Content type is also another common one that just lets you know that the data that it returned to you is in JSON format. So, but there could be a bunch of other information there as well. And then it also returns a body. So this is going to be a JSON payload. So there is basically 2 keys in this JSON payload that each have a value. So the first one is a fact, which is a Catskill division is about 200 degrees. And the second one is a length, and that's 45. So that's the length of that fact. So all we need to do is drop the HTTP GET method, wire in the URL, and run it, and we get this back. I mean, if you run this, you'll get a different cat fact every time you run this, but that's basically all there is to it. Now, if we want to parse that JSON data into LabVIEW data types, and this is a simple example where this JSON payload actually only has 2 keys in it. There can be much more complex ones that could have a lot of data of a lot of different data types. And so you'll often want to convert that to LabVIEW data types so you can work with the individual components. So with LabVIEW, the JSON function, there are 2 JSON functions that ship with LabVIEW. There's a flatten to JSON and an unflatten from JSON. So what these allow you to do, in this instance, I'm using the unflatten from JSON, where I'm basically just wiring in my JSON string, and then I'm defining the data types of the objects there. So I have a cluster that represents the entire JSON object, and in that cluster, I have a string named fact and an integer named length. Just wire that in, and it's going to output my cluster, just this time now with the actual values in it. You can see I ran it again, and now you get a random cat fact that is a string. The average cat can jump 8 feet in a single bound, nearly 6 times its body length, and also a integer representing the length. So that is how simple working with REST can be. And also, just kind of as a plug, the JSON functions that ship with LabVIEW are fine. Personally, I prefer available on VIPM. There's the JDP Science JSON text package. It has a whole bunch more features beyond just converting LabVIEW data types to JSON and JSON back to LabVIEW data types. It has the ability to search objects for certain functions, to return list of what exists in there, to do like different formatting of the string, color coding by data types. So it has a whole bunch of cool features. That's my go-to. For this example, I just demonstrated using the native LabVIEW features, which do work just great. But I personally recommend the JDP Science JSON text tools for that. Wanted to highlight one other great resource. So this is myjsonserver.typicode.com. This is another free tool you can use to just play with REST APIs. So this allows you to test multiple functions. So it can do get, post, put, patch, and delete. So it has basically a data set that just exists in there, and you can actually view it. Here, if you go click, like post, profile, DB, comments, etc., you can see what data is in there, and you can actually do like a get, you can do a post, and you can actually see that data update and get results back. And it's all free, so it's another good kind of training tool. So now, how do we start using things like headers or API keys? So for this example, we're going to integrate with OpenAI, and we're going to walk through step by step on how you can do this in LabVIEW. So over here on the right, I have an example. So this is right from the OpenAI website. So this is just an example of how you can make this request. So first we have this URL, https api.openai.com/v1/chat/completion. So that's our URL. Then we have these -h lines. So the -8 denotes that is a header. And we'll show you how to do that in LabVIEW. And then the -d denotes the data for the request body, and it also shows us the format for the data. So we're going to be sending it a JSON payload, and we're specifying that here by saying, hey, our content type is JSON. And basically we just have two parameters we're sending. We have a model, which is which OpenAI model we want this to run on, and then also the message. So we define inside that message, we define a role, in this example just user, and then the content is the actual message that we're sending. If we have like a question or whatever it is for OpenAI, that's what we're sending to them. So let's look at how to set this up. So the first thing we're going to use is an OpenHandle VI. You can find that in that HTTP client palette. And so what this does is it allows you to chain a bunch of the HTTP functions together. So you can configure a combination of API keys, headers, whatever it might be, before you actually execute your HTTP request. The example we did earlier with the catfax, we didn't need this because all we were doing was doing a get on a URL. But for anything involving, having to write headers, you need to use the OpenHandle VI first and then pass that reference through the other functions. So once we have that, we're ready to now add our headers. So in that same palette, there is an HTTP add header function. So we have here this top one is going to be the actual header name. So our header name is going to be content type, and for the first header, and authorization for the second header. So we need to set that up. I wanted to highlight, by default, this is a combo box. So it has common selections you can just scroll through, but it also just supports arbitrary strings. So you can see on this first one, I have just a combo box here where I could go and I could select something. Authorization isn't in that list, but I can just create a string constant and wire that in, and it will work just fine. This bottom node here is going to be where I'm actually connecting the data related to that header. So the application/JSON, and then here I'm also passing in my API token. Once we have that, we can actually do an HTTP method. So whether that be a get, a post, whatever it is, it depends on what you're integrating with. For this example, we need to do a post. So we're going to drop the HTTP post function and use the post buffer. We just need to specify the URL that we're connecting to, which is listed right here. And then in our post buffer, we're actually going to write this data. So we can just basically copy this JSON structure down here. And then we just need to insert the specifics for our example. So if we want to just run GPT 3.5 Turbo, we can leave that as is. But for our content, we want to update that with the actual question that we have. So this example, what is the fastest production car I can buy today? From there, we just need to add the close handle function at the end. And so this actually closes out that connection. I can leave it open if I want, and I can execute other requests with the headers that I've already generated if I want to. But for this example, we're just making one request, so we can close it out. So from that, we can run our code, and we're going to parse a little bit of JSON, and we get a request like this, where OpenAI answers your question, gives you some details. So it was successful. The response headers we get back also indicate whether the communication was successful as well. And that same format works for other OpenAI functions as well. So for example, DALL-E allows for image generation. We can use those exact same tools, exactly how we set that up, to also query or have an image generated automatically. So this example, using those features, we have a field here where you can put in an image prompt. So a bunch of engineers learning about REST APIs. I can run this code, and it's going to make that request to OpenAI, and it's going to return a whole bunch of data. The main thing here is it returns this URL, and that URL is where we can find our newly generated image. So apparently this is what a bunch of engineers look like that are learning about REST APIs. Not the best picture, but just, wanted to highlight how you can use this. And so we've kind of done some fun examples with what you can do with REST APIs. It can actually be used for a ton more. So integrating with different cloud services, AWS tools, secret stores, different math web services, all sorts of stuff. So it can integrate with all sorts of things. And it's really just those same simple functions that we were using. You just need to implement the specific details of the REST API that you are working with. So that is our crash course on REST APIs in LabVIEW. I hope you guys enjoyed it.